Let's look at building internet access into our Android applications. We'll start by looking at the low-level network stack. Then we will look at some of the patterns through examples of how we can access the internet. Then we'll talk about some of the different types of data that we tend to access when we connect to the internet and look at some of the libraries that will help us process those data. Most modern devices will grant some level of access to the internet, whether that's a cell phone that gets access through its mobile carrier or a tablet that connects to the internet through a Wi-Fi network. In Android, we can build applications that exert granular control over their behavior based on information that we garner about the available networks. For example, you may have an application that is more careful about how much data it downloads if it is running on a device that is currently connected to a mobile carrier, since many mobile carriers will meter their network connections. That same application may be more liberal when it's running on a device that is connected to a Wi-Fi network, since when it downloads information, the user is probably not incurring any additional charges. When building an internet-enabled application, there are certain considerations that we have to keep in mind. First, in Android, access to the internet is considered a protected resource. That means, prior to attempting access to the internet, we must request permission to do so. The permissions that we're concerned with are the internet permission, which is what grants us general access to the internet, and the access network state permission, which is what allows us to query the operating system to get information about the available networks. The second consideration is that Android prevents applications from executing any network operation on its main thread. That is, whenever an application needs to perform a network operation, such as accessing the internet, it needs to make sure that that operation is done in a background or worker thread. In the case of the illustration shown here, we're using coroutines where the coroutine is launched on the I/O dispatcher, which is there to facilitate input-output operations such as network access. Let's look at an example application that demonstrates these basic concepts. As mentioned, before an application in Android can access the internet, it must request permission. That is done by adding a uses permission tag in the Android manifest as a child of the manifest tag. The name of the permission we are requesting is android.permission.internet. This is a singleton XML tag, so we close the tag immediately with a slash right before the closing arrow bracket. Next, we can attempt to write code to access the network. However, prior to doing that, we must ensure that we have defined it in such a way that it does not execute on the main thread. In this case, what we will do is use coroutines. So I will create a coroutine scope that runs on the I/O dispatcher. From here, I can define a URL to access a web server. Once that URL is defined, I can open a stream to read the information from the server as it becomes available. Now, it turns out that the information I would read from this specific website is going to be text data. And processing text data is not done in a stream traditionally. Rather, what we would like to do is buffer that information so that we can process it in blocks. I can then convert my stream into a buffered reader, which will allow me to read one line at a time from the information being read from the server. So if I take a look at what that response is, I will be able to see in my log here we see the response from the server, doc type HTML. Now, why am I getting doctype.html? Well, let's take a look. When I go to the Wikipedia website, I can look at the information that is behind the web page. If I view the page source, I can see text that is in a format similar to what's called hypertext markup language, or HTML. So this is some version of HTML, but we can see that even though the Wikipedia page itself is filled with text and images and other types of media, under the hood, all that the browser is getting from the web server is text, which it then renders to show us the visuals that we see. This text has a lot of different lines, and the very first line of the information that we receive from the Wikipedia web server is doctype HTML. And that is exactly the line that we see in our application. If we would like to see the rest of the information that is available from the server, one approach would simply be to loop over this logic, continuously reading from the buffered reader until we have all the information that the server has provided. What's important to note here is that if we had skipped any of the steps, our application would, in many, if not all cases, throw an exception. So what do I mean? Let us say we had failed to request the permission and we ran our application. We would, in fact, have an exception thrown. Here we see permission denied, and it's asking me if my internet permission is missing, which it is. Separately, if I had failed to execute this operation on the IO thread, but instead had done it on the main thread, I would have yet another exception. Now we're being told that we're receiving a network on main thread exception. So that is something that we would have to address. Finally, if we had tried to connect to a URL that was incomplete, that would throw yet another exception. So here we see no protocol because of this malformed URL exception. So all of these exceptions are being thrown and they can be caught. Kotlin does not have the notion of a checked exception, so we're not being forced to use a try catch. However, you can in fact intercept or catch these exceptions and respond to them accordingly. So if we wanted to read the entire content for this specific URL, what we could do is change our logic a little bit. So instead of reading a single line from the buffered reader, which will give us a new line every time we call read line, it'll give us the next line. What we could do is use a scope function on that return function, on that returned object. So the buffered reader, we could execute a run scope function, which uses the object as the context object. So this reference will refer to the buffered reader object here. And run will return the lambda statement, the last statement rather in this lambda, as the return value. So whatever we put as our last statement is what will be stored in response. So we could do something like this. We could start by defining a string builder. A string builder is the preferred way to build a long string from a series of smaller strings. So I could build a string builder object. And then what I will do is I'll do a loop. And I will say that while readline let. So I'm going to read a line from the buffered reader. I am then going to take the line that I read and I'm going to add it to the string builder. And then I will stay in this while loop as long as the item I just read is not equal to null. This loop I'm going to close off. I've basically put the entire loop logic directly inside the while parentheses. I am reading something, and every time I go through the loop, this is going to change. Whatever line I just read, I add it to my string builder, so this string builder keeps getting longer. And then at the end, I check to see if this particular thing is null. It's going to return true or false, and that will determine if I stay in the loop. So without having to have an explicit loop body, I'm able to have the loop logic. So once this gets to null, which is what will happen when I read to the end of the buffered reader, I'll exit the loop. And having exited that loop, I can now call string builder dot to string, which will return this string that I built up in this loop to response. It will be the return value for this run scope function. And if I now run this updated application in my logcat, what I hope to see is the full content being displayed. So we scroll to the end, and here we see the response is this very long list of content, including doc type. So we've created one long string. If we wanted this string to be a little shorter, we could append it well, not shorter, I'm so sorry, but instead of having one long string, we would have a series of broken lines. What I could do is add a new line character along with it. Well, I guess I could just use like that. So we're creating a string with it, and which is the string that I read from the read line character, and then a new line, which would basically result in a new line after each read. So the result becomes this. So now it will look a lot closer to what is displayed when we view the source for the browser. Now, having the information displayed like this is all fine and good, but this is in the log. If I want to actually display this information in the user interface of my application, then what I need to do is probably update this text view. Looking at my activity main, I see that this text view currently does not have an ID, so I'll give it an ID. I'll call it text display. Then from my main activity, I will reference that view now. At this point, what I would like to do is simply say, have this text display's text value be equal to response, and hope that that would result in me seeing the content of the page. But what we know about coroutines is that since this is executing on the IO thread or the IO dispatcher, then running this application will actually result in a crash. We switch over to the logcat, we should be able to see it. So here we see it's telling us called from wrong thread exception. Only the original thread that created a view hierarchy can touch its views. That's just a fancy way of saying, of course, that only the main dispatcher and the main thread is able to access the view system. What that means is that this specific line needs to be called with context dispatcher's main. And now from within this block, we're able to manipulate the view system. And we can see the content displayed here. So this is the basics of connecting to and pulling information from the internet from within an application. This is very low level, and whereas sometimes it is necessary to use this low level code, the reality is in many scenarios, you can actually rely on a library to do a lot of the work for you. So what we can do now is look at replacing this code with a library that would be able to fetch the information for us and return it. For that, we're going to use this library called Volley. Volley is simply a network library that allows you to perform many of the operations that essentially require some of the low-level code that we've just been writing, the ability to query a web server to pull information down or to post or send information to a web server. Because Volley is an external dependency or an external library, we need to add the dependency to our project. So I can do that by simply taking the implementation line and adding it to my build.gradle file. I'm adding it to the build.gradle for my app module. Once I hit sync, this will add Volley to my project. Now, there is a guide on the Volley website that will tell us how to use Volley, but basically it boils down to performing a few steps. The first step is getting what's called a queue. So we can create a Volley queue by simply calling Volley new request queue with a reference to context. In this case, the context is the activity reference. Context is a necessary component to get access to the network. Once we have the queue defined, we can now create what's called a request and then have that request passed to the queue, and it will then be processed by Volley in the background. What's interesting about using a library like Volley is that we don't need to explicitly perform any of our operations in the background, since Volley in its own implementation is already performing the operations asynchronously, removing them from the main thread. So I'm just going to create one big comment block here. And then I'm going to replicate this functionality, but using Volley. To do that, I'll simply create a new string request. I'm creating a string request because the information that we're going to get back from the web service is considered a string, even though the protocol or the format that the information is in is called HTML. Volley still simply sees it as a string. So I'll create a request, string request. This is something that becomes available to me because I've added the Volley library. My string request needs a few arguments. The first is the method that we're going to use to request the information. The method in this case is the HTTP verb that we will be performing. In order to fetch information from a web server, the method that we use is called get. So we will simply type request.method.get. Now at this point, I'm being told that Android doesn't know what I'm referring to. That just means I need to import the correct class. So I will import my request class from Volley. So here is the proper import statement. So Android knows which request class I'm referring to in this code. Now that I have my request, I'll specify the next argument, which is the URL. That will simply be my URL as a string. Next, I need to specify a callback that gets invoked if my request is successful, and another callback that gets invoked if my request fails. Because of the functional interface feature of Kotlin, I can actually specify both of those callbacks as lambdas. So I need only specify one lambda for the success listener and another lambda for the error listener. Now I can write the code that I would like to be executed if I made a successful request. The input to this lambda, the argument that will be passed to us, is a string referenced using the it keyword. And that argument is going to be the information pulled from the website. So I could get the very same result as I had when I was writing the low-level code by simply saying text display dot text is equal to it. I could subsequently get an error message be displayed if there is some error with connecting to the specified URL. Now that I've defined my request, I just need to add that request to Volley by telling it to add my request. So all of these steps could now be combined simply to say get the Volley request, get the Volley queue rather, and then add this request. I'll just cut and paste inside the add. And when I do it this way, I don't even need any other variables. Everything is just done in a single statement. Running my application, I now get the same result as I did before, but with much more straightforward code, much cleaner code. No need to worry about concurrency and coroutines. Everything is just done for me inside the library without much overhead or without much work on my part.